Lesson 10.5 covers the laws of logarithms. So the basic objective is to learn and apply the properties of logarithms. So you can see those law of logs written in that blue box. So for a log with any base, we know that that base has to be greater than 0 and not 1. Here are the three most important laws. So for number 1, you see here, taking the log of a product of two numbers is the same as taking the log of each and adding them together. Similarly, the log of a quotient is this equivalent to subtracting those two terms. And then another important law, if we take the law of some number with an exponent, that's equivalent to this exponent being a coefficient out in front. So we're not going to prove these laws today. What we're going to learn to do is how to apply them. So here's our first example. It says express each logarithm in terms of log base 2 of m and log base 2 of n. So what that means really is that we're kind of expanding this log. So the first thing I'm going to notice is that there's a power of 4 here. So what I'm going to do is use that third law that we saw and rewrite that as the coefficient. So it's 4 times log 2 mn. Then I'm going to apply my second rule, which is that this part here, this log 2 mn, can be broken up into log base 2 of m plus log base 2 of n. And then just not forgetting about that 4, we'll distribute that through. And now we've answered that first question, which is to write it in terms of log base 2 of m and log base 2 of n, which is what we've done here. We've expanded it. So let's do the same thing here. Let's expand this log. So we're just using those three laws. So the first thing that I'm going to notice is that this is a quotient, right? We have a numerator and a denominator. Our second law told us that that can be written as log base 2 of 3 x squared y cubed minus log base 2 of 4 square root z. Okay, now looking at both of those, on the inside of this log, we have multiplication. Using our first rule, we can rewrite that as addition. I'll use a different color to show you what I'm doing here. So this one that I've outlined in pink can be written as addition for each of those terms. So we have log 2 of 3 plus log base 2 of x squared plus log base 2 of y cubed. So minus, and then I'll do the second one in blue, we can do the same thing here. We're going to have log base 2 of 4 plus log base 2 of the square root of z. One more rule to apply. Anywhere that we see these exponents, we need to bring them down and make them coefficients. So let's go ahead and do that. We have, I'll just go back to all black here. We have log base 2 of 3 plus, this is 2 log base 2 of x plus 3 log base 2 of y. Again, what I did in that step there for these two is take the exponent and make it this coefficient. Exponent is equivalent to this coefficient. So now distributing this negative and doing the same thing here, we're going to have minus. Now think of this 4 as 2 squared. So that really, it does have an exponent even though it doesn't look like it right now. So if we think of this as 2 squared, we can take 2 out in front. So 2 log base 2 of 2. Again, we're distributing this negative, so that's minus. And again, it doesn't necessarily look like it when it's written like this, but this z does have an exponent. Remember, the square root is the same as the 1/2 power. So that exponent there is 1/2. So I can make that my coefficient. So it's log base 2 z. And there it is. The directions were to expand, and now we've done that. We've fully expanded it. We've applied all three laws. Okay, so here we're going to do the opposite. We're going to condense this. So write it as a single log. Remembering that if there is no base for a log, that's assumed to be base 10. So I could rewrite each of these here with a little base of 10. Base of 10. If it's not there, it's assumed to be 10. Okay, so let's get to it on this problem here. We're trying to condense it. We're trying to move it back into one log. So the first thing I can do is take this coefficient of 4, and I know kind of reversing those rules what we've talked about, that's the same as having an exponent of 4. So I have log base 10 of x minus log base 10 of y to the 4th. But we want to condense this all the way into a single log. Well, based on our laws, I know that subtraction is the same as writing this as a quotient. So I can say log base 10 of x over y to the 4th. Oops, sorry, that was an ugly 4. And now we've reduced it to just one single log, which is what the directions wanted. Trying that here with this second one, we're going to condense this whole thing into a single log. I'm going to move this up a little, give myself room. So start with the exponents. Go ahead and rewrite any coefficients you see out in front as an exponent. So that's log base 10 of x to the 5th. Log 2 we'll just leave. Plus, this is log of y to the 1/3, which is the same as the cube root, don't forget. Plus log of 7. Okay, now I'm going to go through and any addition is multiplication and subtraction is division. So addition, that's positive, positive, positive. All three of those are being added together. So that's the same as log of x to the 5th, y to the 1/3 times 7. I could have written that 7 out in front to make it prettier. We'll do that on the next step. And then we still have this minus log 2. So now subtraction is the same as writing this as a quotient. So what we really have is log of a quotient, where this first piece here is the numerator. Again, I'm going to just switch the order so it looks nicer. And then this second piece here is the denominator. So over 2. And now we've condensed that to a single log. Okay, here's some examples similar to what you'll see in your homework. So it says if log base 10 of 9 is 0.95 and log base 10 of 2 is 0.3, then you're going to find here log base 10 of 9 halves and log base 10 of 1 over 2,000. So the idea is to get everything in terms of these decimal approximations that we know. Now, in order to get there, we need to know this other two definitions here. So I said first, what is log base 10 of 10? Well, remembering our definitions, log base 10 of 10, if I was to convert that to exponential, let's say, let me write it down here. I take log base 10 of 10, I set it equal to x, and I try to solve for x. So converting it to exponential gives me 10 to the x is 10. Well, 10 to the first is 10. So this is equal to 1. So whenever the base here and this number match, you're always going to get 1. Because anything to the first power is going to equal itself. Similarly, if we do that over here, this is going to be 10 to the x equals 1. Well, the only number that makes sense there is 0. Anything to the 0 power is 1. So those are two definitions that we'll use as well, in addition to the two that the book are going to give us for these examples. Okay, example 5. Find log base 10 of 9 halves. What I'm going to do is try to break this down into one of these 4 definitions that we have. Because I don't know what log base 10 of 9 halves is, but I know what log base 10 of 9 is and log base 10 of 2 is. Well, I know that division is the same as subtraction. So this is just log base 10 of 9 minus log base 10 of 2. So based on this definition up here, log base 10 of 9 is 0.95. So that's this first one here. Minus log base 10 of 2 is 0.3. And now I can just do that subtraction. So we get 0.65. Same idea here. Let's take this division and write it as subtraction. So log base 10 of 1 minus log base 10 of 2,000. By the way, I'm writing base 10, but you don't need to. You could just write log 2,000. So this first piece here, log base 10 of 1, we know is 0. But now we have minus log base 10 of 2,000. We don't know what this log of 2,000 is, but we do know what the log of 2 is, and we do know what the log of 10 is. So let's try to break that down, because we know 2,000, we can break that down into a product. So what we have here is, let's write it like this. Log base 10 of, instead of writing 2,000, I'm going to write 2 times 100. Let's start with that. So 2 times 100, so I have minus log 2 times 100, I'm going to write as addition. So log of 2 plus log of 100. So far so good, because I know what log base 2 is. That was given to me up here. But I still don't know what log of 100 is. So we're going to have to break this down a little bit more. So 100 is just 10 cubed, right? So this is plus log of 10 cubed. So bringing down that exponent, we have 3 times log base 10 of 10. Now this is in terms of things we know. So log base 2 we know is 0.3. Log base 10 we know is 1. So we can just plug that in. So we have minus log base 2, I said, or log of 2 is 0.3, plus 3 times log base 10 is 1. So I have on the inside there 3 plus 0.3, but then times that negative. So the answer is negative 3.3. Okay, same example. Let's just do one more here. So we already filled this out on the first side. We know log base 10 of 10 is 1, and log base 10 of 1 is 0. So let's find log base 10 of 36. So let's rewrite that as a product of things we know. So let's rewrite 36 as, I'm not going to write base 10 because that's redundant. We know it's base 10 if it's not written. So I'm going to rewrite that as 9 times 4. Now using our laws of logs, that's the same as log of 9 plus log of 4. Now log of 9, great, we're where we need to be because we know that that's 0.95. But log of 4 isn't any of these 4 definitions yet, but we can make it that because I can rewrite 4 as 2 squared and then use this log of 2. So we know log of 4 is 2 squared. First of all, then I can take that exponent out in front, so that's 2 times log of 2. And log of 2, given to us at the top of this page here, is 0.3. So now I have 0.95 plus 2 times 0.3, which is 1.55. Okay, between this lesson and 10.5 day 2, we're going to learn how to solve equations that have logs in them. Notice for these type of solve problems, the base is unknown. So I just want you to notice that we don't know what the base is there. Okay, so here's the process for this. When you don't know the base, what we want to do is get one log on one side and one log on the other. So just kind of, if I write this in shorthand here, the goal is to get a single log on the left-hand side of the equation and a single log on the right-hand side of the equation. So let's go ahead and do that. We already have a single log, meaning just one log on the left-hand side, but we have 2 logs on the right. So what we're going to do is condense these like we've done in these earlier examples. So we have log base A x equals, okay, let's do some condensing. So first we can rewrite this 3/2 as an exponent. And before we go further here, let's go ahead and simplify 9 to the 3/2. I can kind of do some scratch work over here. Remember, 9 is 3 squared, and then if that's raised to the 3/2, those 2's are going to get canceled, so because we multiply these together. So that's 3 cubed, which is the same as 27. So let me just write that there. It'll just look a little bit easier to work with. So what we're trying to condense is log base a of 27 plus log base a of 2. Okay, so we're still working on condensing the right-hand side into one log. Now that we have log base a of 27 plus log base a of 2, we can use our log rules to rewrite that as a product. It's 27 times 2. Okay, so if we multiply that together on the right-hand side, we have log base a of 54. So now that was the goal. The goal was to get, like I said, one log on the left-hand side and one log on the left-hand side. So we're saying this log is equal to this log. Well, if they're both the same log, then this x needs to be equivalent to this 54. So we can just take this and set them equal to each other. And we've arrived at our solution. X is 54. Okay, one more solve example here. Notice this time you do know what the base is. The base is 3. So a little different process here. So I'm going to kind of jot it down in words again. When the base is known, so I wrote known base, the goal is to get one log on one side, but the other you just want to be a number. So what we're going to do at that point is we can convert to exponential. So those are the steps there. Get it to a single, when you know the base, get a single log on one side, a number on the other, and convert to exponential. So let's do all those steps right now. So here we go. On the left-hand side, there's 2 logs. We need to condense that to 1. Well, we know addition is the same as making it the product of 6 and x plus 2. So we have 6 times x plus 2. So just cleaning that up a little, we have log base 3 of 6x plus 12. Okay, so we've completed this step. We have a log on one side, a number on the other. So a log on this side, just a number on the other. Now what we're going to do is convert this to exponential, just like we did before. So this is going to be 3 to the third is equal to 6x plus 2. So 3 cubed equals 6x plus 2. And now it's just basic algebra. We're done with logs. They're gone. They're not in this problem anymore. So now we just need to rearrange and solve for x. So we know, 3 cubed is 27. We can subtract 12 from both sides, and we get 15 equals 6x. We can divide by the 6 on both sides, and then reduce, and we get 5 halves equals x. Okay, that was lesson 10.5, day 1. Go ahead and check Schoology for homework.